start, as you see in this class, because I have to review at least a little bit something that is required here. Yeah. Okay, is there anything else here? I've seen you guys using distributing here. This is not. So your 2 goes away, divide both sides by 2, and you have 3 solutions. From here you have x equals 0, from here you have 1/2, and from here you have -4/5. So there is nothing. You don't want to go back to terms. We don't like terms. We love factors. We don't want terms. I can't solve if you give me a bunch of 6 terms. I'll say, what? But if you give me factors, does it make sense?
Yeah.
Okay. Is there anything else in number 3?
Yep, I have a question about it.
Yes. So that's an inequality. It's a linear inequality. Linear.
One thing I would say is it's not a space.
3 minus 7x less than 3x plus 6. So here's what I recommend. Again, use the method you like. But all I like to do is I normally keep the variable on the left. Sometimes, very rarely, on the right. But most of the time on the left. And when I move a term to the other side, I only change its sign. When I move a term to the other side, I only change its sign. That's all it happens. So I will move this, and I will move this. Negative 10x less than 3. So 3x became negative on the other side, and 3 became negative on the other side.
Oh, okay. Software.
I recommend move away from minus 3x, minus 3x, minus 3, minus 3. I recommend move away from that if possible. And then I divide both sides by negative 10. Yes, awesome. So every time we divide both sides or multiply both sides of an inequality by a negative number, do we remember that?
Yeah, it'll come back.
That we have to switch the symbol, the inequality symbol. Okay. In interval notation, greater than, interval notation, negative 3/10 to infinity. X is found in the interval. Any questions here? Any questions? Any questions? Please, anything. Are we okay? Everyone? Again, I don't want to leave anyone behind. Okay, number 4. Let's work on number 4. Let's graph. Let's pick a function and graph. Which function are we graphing? Okay. Okay. You chose the easiest one. Let's do another. Of course. Yes, everyone is choosing the easiest one. That does it. How are we going?
Okay.
Okay. That's okay.
Alright, so
How are we doing? Okay, other than a linear function, can everyone graph the first one? Which one are we going to graph?
yeah,
Which one? X squared? The square root of x minus 2? X plus 2? Okay. So let's start with that. And which other?
C3.
So we want B and C? I'm sorry, you said C and?
C3. That you wanted D and I wanted
So you want C and D?
E.
Okay, let's. We can do all of them, but I really would like to make progress with this.
Okay.
So that's my page 6. So let's look at C. Y equals the square root of x plus 2. What type of function is this?
This is a radical.
Yes, that's true. It's a radical function, specifically square root. I completely agree. What is the domain of a square root? What can I take the square root from? What type of numbers I can take the square root from?
Real numbers. Positive.
Only positive and?
0.
Right. So the square root exists from positive or 0 only. Now I would like to find the domain of this function. What do I have to write and solve in order to find the domain of this function?
You said equal to 0.
That's your hint. That's your hint. So what would you tell me to write?
-2.
I cannot write -2.
For x.
I cannot. I have to write something and solve for everyone to see. You may have performed the calculations in your head, but I still have to put something on paper for everyone to see how we got to that. So what do I have to write? Okay, let's start again. What can I take the square root from? Positive or?
0.
Perfect. The function. What does it take the square root from? No.
X plus 2.
X plus 2. Therefore, x plus 2.
Would be equal to 0. 1 to 0.
Okay, let's start again.
Or sorry. Square root of x plus 2.
Okay, one more time. What can we take the square root from? What can we take the square root from?
Positive 0.
Good. This function is the square root of?
X plus 2.
Good. Therefore, x plus 2 must be
Positive Point 0.
How do I write that? Excellent.
Greater than or equal to 0.
Right. Please dictate the whole thing. I cannot just write greater than or equal to 0.
Let's do
Oh,
greater than
okay.
2. Gotcha.
Awesome. This is the condition of existence of this function. We agree?
Yeah.
Perfect. Then my next step would be,
Solve for x.
good. What do I do?
2.
Okay. Then just dictate.
X is greater than or equal to -x.
Awesome.
Okay.
Finally, can anyone give us the domain of this function?
-2 to infinity.
Awesome. With brackets, parentheses, what do I write?
Parentheses. Or sorry, bracket and parentheses.
Awesome. Good. Without this, I cannot start working on this problem or graphing without its domain. I recommend use a horizontal chart, not a vertical chart. X is horizontal. X is not vertical.
Right.
So I recommend this. Of course, it's up to you. I need to see in the chart what values, from what to what.
-2
To
infinity.
awesome. So please pick three values of x and give me the answer. I recommend do not pick 3 because 3 plus 2 is 5 and the square root of 5 kind of difficult to plot. So I'm sorry. 2 is a good one. 0 is not a good one. 7 is a good one. Too far. 4 is not a good one. 4 plus 2 is 6. The square root of 6. -1 is a very good one. Awesome. Good enough. Good. So please plug in -2 and give me the answer. Awesome. Please plug in -1 and give me the answer.
1.
Awesome. Please plug in 2 and give me the answer.
2.
Very good. Please plug in 7 and give me the answer.
3.
Awesome. Thank you very much. From left to right, the first ordered pair, please.
0, -2.
No.
Oh, sorry, -2, 0.
Awesome. Next ordered pair, please.
-1, 1.
Next ordered pair, please. And the last one.
3.
4, 5, 6, 7, 3. Ready?
Yep.
I would like to identify the range for this function, please. We have to look at the graph.
0 to infinity.
Very good. The range is 0 to infinity, from the lowest y value to the largest y value. Awesome. Okay, we also wanted to look at the absolute value function. I should have not mentioned that. So y equals the absolute value of x minus 3 minus 2. What type of function is this? The absolute value, of course. Good. Awesome. Now, whenever we are asked to graph a function, like we just did 3 minutes ago, what did we find first? Excellent. Awesome. The domain. Perfect. So what is the domain of this function? Without the domain, my hands are tied. I can't do anything. Correct. Absolute value has domain, all real numbers. There is no denominator. I cannot exclude anything. There is no square root. I don't have to write any restrictions. If you give me any x, I'll give you a y back. Awesome. Thank you. Good. So let's pick some values for x. Okay, let's say -1, 0, 2, 4, 6. Good. So let's plug in negative 1. So negative 1, yes, minus 3 is negative 4. Negative 4, the absolute value of negative 4 is 4 minus 2 is 2. Awesome. Let's plug in 0. 1. Awesome. Let's plug in 2. We should always also use 3 in a minute, you'll see why. Because it's right. So 2 minus 3 is negative 1. In absolute value 1. 1 minus 2 is, yeah. So we should also use 1 because the x and y intercepts are important. That's why I'm getting at. So this is negative 1, and when I plug in 1, I get negative 2. Yes, I get 0, so that's why. Good. So let's plug in 3. 3 minus 3 is 0, so then minus 2. Very good. That's no. So when we plugged in 3, that was negative 2. When I plug in 4, 4 minus 3. So when I plug in 2, yep. Very good. And when we plug in 6, 1. Good. Good enough. We have way more than we need. From left to right, the first ordered pair, please. Next ordered pair. Next ordered pair. Next ordered pair. One, two, three, four, five, 6. Very good. Can anyone give us the range of this function? Very good. With a bracket. Very good. Okay. Some of these problems will be repeated throughout the semester, but we want to have a head start and we want to be able to understand this and not have difficulties later. Okay, so we have 15 minutes left. Let's work on these 3 problems together. Yes. So let me copy f of x. So 2 for x less than or equal to 0, 1 minus x squared, and the square root of x plus 5 for x greater or equal to 4. Yes. Few of these things will come back and we will work on them more. Okay, what type of function is this? Awesome. Indeed. It's defined in pieces. It's piecewise defined. Very good. Do not get intimidated by it. It just has 3 portions. It has a portion for negative infinity to 0. It has a different portion between 0 and 2. And it has a different portion between 4 and infinity. Right? They will not overlap. What the graph between negative infinity and 0 is one graph and it cannot go anywhere else. The graph between 0 and 2 is just one graph and it will not go anywhere else. And the third piece or graph will be between 4 and infinity. Good. So question for you. What is the domain of this function? I can graph anything. If I can't establish its domain, I don't know what to do with it. So before you answer, Can anyone change this into interval notation? I already said it myself a second ago. Awesome. Very good. Can anyone give us the interval notation for this?
Bracket.
There are no equal symbols, so I cannot have a bracket.
Parentheses.
Yes?
True.
Very good. So, and for this one?
Bracket.
Yes?
Or,
Awesome. Perfect. Okay. From here, I think it's easier to establish a domain. So look at those intervals and tell me what is a domain of this function.
+2.
Awesome.
Parentheses. And 4 to the +2.
Awesome. Okay. So between negative infinity and 0, I see a left bracket. I'm going to write it under 0, a left bracket facing this way. It's this one. I'm just copying it here under 0. What should I copy under 0 on the other side? Good. What should I copy under 2 facing left? Very good. Awesome. Now, there is a gap, right? I'm jumping to 4. So I use a bracket, this bracket, facing to the right, and I cannot use anything here. Obviously, the domain of this function is negative infinity to
2.
with a parenthesis, union 2.
Awesome.
That's it. So the domain of this function is negative infinity to 0, union 4 to infinity.
I mean 2. On the left. Sorry.
Oh, I'm sorry, yes. Thank you very much. Union 4 to infinity. Very good. I know that this is an overkill, but I would like you to tell me which function will you use between negative infinity and 0. You can only use one function. Which one? Which function will you graph between negative infinity and 0?
This is less than or equal to 0.
Which function will I graph on x for the interval negative infinity to 0? Which function will I graph? It's right there. You just have to read it. 2. Which function will you graph between 0 and 2? Say it again. Is that okay?
Yeah. 1 minus
It's right here. This is the function.
Yeah.
Is it okay? Oh, you said that and I didn't hear? I'm sorry. Forgive me. Okay. Between 0 and 2, which function will you use?
1 minus x squared.
Awesome. And finally, which function will you use between 4 and infinity? Right. As you see, it's an overkill. I already have it right there under my nose, but it's better to put it because these may not be in the correct order from left to right. So it's better to establish what I'm doing. Okay, so now between negative infinity and 0, give me a couple of values of x. And you cannot say 4 between negative infinity and 0. Negative 4, okay. Another one. Perfect. So when x is negative 4, how much is y?
2.
Awesome. When x is negative 2, how much is y? When x is 0, how much is y?
2.
Awesome. Perfect. Now, bless you. Now I'm in between 0 and 2. So please plug in 0 in the next function. And you should say no. I refuse to plug in 0 in this function. Why?
Not part of that function.
Exactly. It's not part of that domain of the portion. Bear with me and still plug in 0. And you'll see in a moment why. Please plug in 0. 1. Let's also plug in 1 because it's between 0 and 2. What do we get?
0.
Awesome. So now please plug in 2 and you should be appalled again and say no. You can't, right? Bear with me, please plug in 2.
Negative.
Good. I'll come back in a second. So now please plug in 4.
3.
Good. And find another number to the right-hand side of 4. So the next one after 9, we will be 16, right?
Yeah. 1.
11. So plug in 11. 11 plus 5 is 16. The square root of 16 is
4.
awesome. So I know I owe you an explanation here. In a moment, I will get to that. Good. From left to right, please give me the first ordered pair. Negative 4,
Okay.
comma 2. The next ordered pair, please.
Negative 2.
Next ordered pair.
0, 2.
Is this a full point?
No. Well, full point.
Full or open?
It's full. It's practically
Yes,
full
because 0, 2.
wrapping the-
Awesome. I agree with that. Good. Now I'm in the middle. Notice that I cannot extend this graph to its right. It's done. Good. So please give me the next ordered pair.
Negative 0. 0, 1. 0, 1.
Good. Is that a full point or not?
That's open.
Yes.
It's not.
So that's why I had to plug it in, because if I don't plug in 2 and leave it open, 0 and leave it open, then I will have to plug in 0.000000000000001. Do you want to plug in that? Or you want to plug in 0 and leave it open? Correct. Okay, so 1 comma 0, full point, and 2 comma negative 3.
This one's open.
Very good. This will be an open point, because otherwise I would have had to plug in 1.999999999999999. Instead, elegantly I plug in 2 and I leave it open. Good. So this is a quadratic function with a maximum opening downward, and this will be the piece. Finally, 4 comma 3. So this was 2, 3, 4, comma 3. Full point or open?
Full point.
Awesome. And 11, I can consider that, so it's this. Very good. So this is the graph of the piecewise defined function. Notice that there is nothing here. The function is not defined between 2 and 4. Can anyone identify the range of this function? So it's negative 3 to 1 union to just 2. I cannot use brackets or parentheses for one number only. Union 3 to infinity. Yes. Thank you. Thank you. Any questions? Piecewise defined functions appear to be difficult. If you understand the mechanism or use a different method, I'm fine. You will have no difficulties with them. Okay, I'm going to let you do this on your own. Find the slope and the y minus y1. So the slope, y2 minus y1 over x2 minus x1, and then y minus y1 equals the slope times x minus x1. And let's just work on the last one. So 1 divided by x plus h. Everything squared minus 1 over x squared divided by h. Before I forget, so you have the lecture notes. I don't have the video here.
That's okay. 3 minutes.
I don't know why I don't have the video there. Anyway, so please redo all problems from this. And I still have 3 minutes to work on this. I don't know why you're packing just yet. I hope you're not. Okay, so I'm kindly asking you to watch this video with the lecture notes and these 3, at least.
This is for the next class.
For the next class, please, so we can make progress. So including 1.7 through 1.10, it will be for next time. But till this point, 1.4, 1.5, 1.6. Because it's a 13-week class, our class ends at 7:10. I didn't forget that to let you go. I'm normally very respectful of your time, but I have 2 more minutes. Okay, so what is this?
Rational expression.
Right. Furthermore, it's called complex. Why? Because it has fractions, operations with fractions at the top, and possibly operation with fractions at the bottom. So it's called complex. Complex rational expression. Good. The denominator is h over 1. What about the numerator? What is the least common denominator in the numerator? They are both factored. I cannot factor x plus h squared, and I cannot factor x squared. They're all factored. So then what? Say it again.
Did you use cross multiply now?
Be very careful. I think I know what you mean. Cross multiplication is only in a proportion. So I know, I don't know why, but students are taught in high school, cross multiply. It's not the cross multiplication rule. Maybe they mean something else.
Well, yeah.
But just to make sure. Okay, what is the least common denominator here?
X squared times x plus h squared.
Of course. And I know, Paul, that's what you mean. You mean to multiply the top of the first fraction by what it does not have, and multiply the top of the second fraction by what it does not have. I understand, but just be careful with that.
Okay.
Perfect. Good. So can anyone dictate the numerator?
X squared
Awesome. Minus?
x plus h squared.
Yes, but we have an agreement, and I want to use my agreement. And I want you to tell me what it is. We are not foiling. We're not going backwards. We're not foiling anymore. So, x plus h, everything squared. How many terms?
So x plus
We
h.
said that when we square a binomial, we always get a trinomial. So then what do I have?
X squared
Yes?
is 2xh
Yes?
plus h squared.
They're all minus because of this. Good. Awesome. So as you see, these two go away. I copy the top, negative 2xh minus h squared over x squared x plus h squared times, how do I divide two fractions? I copy the fraction from the top and I,
Use a reciprocal of the other.
yes, flip or use a reciprocal of the bottom. Very good. There is a common factor at the top, which is with negative. I agree. I didn't mean to write it here. Okay, so then, what is left in parentheses after I factor out negative h? And we're done. Yes?
2x plus h.
Very good. So finally, what do you think will go away? We only simplify factors? I apologize for holding you to finish this. I will finish 2 minutes earlier next time. I apologize.